Hello everyone, my name is Dr. Dixit, Assistant Professor of Mechanical Engineering in ABES Engineering College. In continuation of our lecture series, we are continuing with the third video in which we'll be discussing about the engine terminologies of the internal combustion engine. Let's get started. In the engine terminologies, we'll be discussing about the 6 major terminologies of the engines, which is very much required to describe, to understand what the internal combustion engine's configuration is all about. So these terminologies include bore, stroke, dead center, swept volume, clearance volume, and compression ratio. So first one is bore, second is stroke, third is dead centers, the swept volume, clearance volume, and the compression ratio. So let's understand what the bore and stroke is. In our previous 2 videos, we have understand that yes, this is actually the combustion chamber. In this diagram, where it is depicted, this is a closed chamber, internal combustion engines, the closed chamber, the combustion chamber. This combustion chamber, the black lining is the cylinder. This is the piston, and there are the inlet valve and the outlet valve. Okay, and the pink space here highlighted, this is the volume within the cylinder. So the white space here and the pink space here, these are the both volumes of the engine. They are the 2 different volumes. I'll be categorizing it. And the combined volume is the total volume of the cylinder. So the first terminology is the bore, and bore refers as the diameter. That means the diameter of this cylinder, internal diameter of this cylinder, where the pistons reciprocate. So the inner diameter of the engine cylinder is called as bore, and it is represented by D. The letter D. D stands for diameter. So whenever we solve the numericals or when we configure the engines, we always refer D as the bore of the cylinder. That is the diameter of the cylinder. The another terminology is the stroke. Stroke is referred as the linear distance traveled by the piston. Linear distance traveled by the piston, moving from one end to the cylinder, moving from one end to the other end of the cylinder. That means one end is of the top and other end at the bottom. So from top to bottom, when the piston reciprocates or when the piston moves, the linear distance traveled is the stroke of the piston or the stroke of the cylinder. So it is represented by the letter L. L here stands for the length. So the length of the cylinder here, that means from this point to this point, this is L, and this is D, diameter. So D and L are the 2 terminologies, diameter and the length, which is referred as bore and stroke in the automobile and the engine terminology. Now the other part is the dead center. You refer dead center at which point? What are those centers? What are those points which we referred as the dead centers? So dead centers are named because where the pistons cannot move ahead, the point at which or the center at which the piston cannot move ahead of that point is known as the dead center. That is the last point at which the piston can go. So for example, here they are referred TDC and BDC. So in vertical engines, top position of the cylinder is called a top dead center. Top dead center is referred as TDC in the nomenclature. So here it is mentioned top dead center. So the pink line on the top of the side of the engine of this volume is referred as TDC point or top dead center. And BDC, bottom dead center. So when the engine is at the bottom position of the cylinder, is called as bottom dead center, BDC. So this is the point after which the piston cannot go beyond or cannot get more down in the position at the last of the cylinder part. So this is the last point. And because the connecting rod is connected to the crankshaft, so crankshaft has a particular dimension and position. So crankshaft will not allow this piston to move further. So the last point where the piston, the head of the piston will lie down will be the bottom dead center. Okay. These are those two dead centers. Now, the third terminology will be the swept volume. Swept volume is the sweep volume. That means the volume or the area swept by the piston. So the volume displaced between TDC to BDC position. That means the volume between the TDC to BDC. That means the volume highlighted in the pink color in this diagram. This volume is called as swept volume because this is being swept by the piston from the point TDC to the BDC. So the volume displaced by the piston in one stroke. When a piston goes from TDC to BDC, it is called as stroke or one stroke of a piston within the cylinder. And the volume which is swept by that piston is also known as stroke volume or the swept volume. It is referred by the notation Vs. V stands for volume, S stands for swept or stroke. That's why it is referred as Vs. So Vs is the swept volume. Now the other volume, here it is represented as the clearance volume. So this is the clearance volume. Once the piston moves from the position BDC to the position TDC, that means in upward direction. When the piston moves in upward direction from BDC to DDC, the entire volume which gets compressed and the volume left in this white area, which I'm highlighting with the yellow, this volume is known as clearance volume. Why it is called as clearance volume? Because this volume is leftover space which is provided as a clearance for the piston and the cylinder head. So this piston and the cylinder has a particular gap or a particular space or a particular clearance is provided so that the piston should not strike the valve and the head of the piston every time when it's reciprocated. So to avoid the striking of piston, we provide certain gap. And this gap is always fruitful for us to have the compressed charge or the air and fuel mixture after the compression stroke. It gets stored or it gets compressed within this volume. So the entire compressed volume will be in this clearance volume. That's why we can refer as volume contained between the piston top and the cylinder head when the piston is at the top position, when the piston comes to TDC, that is TDC. So this compressed volume is known as clearance volume. So in this diagram, figure A represents the displacement volume. This displacement volume is also called as swept volume or stroke volume. And the figure B, figure 2, represents the clearance volume. This clearance volume is represented by the letter VC or with the annotation VC. V stands for volume and C for clearance. So there are two types of volume. One is swept volume and second is clearance volume. Swept volume is highlighted in the white region here, and this is the white region above TDC, and swept volume is represented by the volume between TDC to BDC, that means pink. Combining both will give us the stroke volume. The total volume of the engine is swept volume plus the clearance volume. This is the total volume. So stroke volume Vs can also be represented mathematically. Vs is the volume. So volume of a cylinder, we have a general mathematical formula, pi r square L. Pi r square L, that means this is the volume of a cylinder. Pi r square H we refer as when cylinder is horizontal, then we can represent it by the letter L or H. So height and length of a cylinder are the similar thing. Then we have the radius of the cylinder and we have the formula for volume, that is pi r square L. When we convert radius into diameter, so the formula gets converted into pi by 4 d square L. So this becomes the stroke volume formula, that Vs here stands, or the formula, the mathematical expression for stroke volume is pi by 4 d square, where d is the port, the first terminology of ours, and L is the stroke length, the length of the cylinder or the height of the cylinder. So the simple formula for volume of a cylinder gets replaced here by the stroke volume, that is pi by 4, this pi by 5. So this is our stroke volume, the volume highlighted in the pink color. After that, one more important terminology comes, that is the compression ratio. So what is the compression ratio all about? Compression ratio is obviously a ratio. This ratio is of a total cylinder volume to the clearance volume. That means it represents how much charge, how much fluid which is entered into the combustion chamber gets compressed, at what ratio it gets compressed. So all the charge which is entering into the cylinder, it occupies the volume of the total cylinder. That's why the volume, the total cylindrical volume divided by after compression, the volume which is after compression. So the volume which remains after compression is the clearance volume in the white region. Okay. What is the total cylinder volume or the volume of the total cylinder? Swept volume plus clearance volume. That means VS plus VC. This is the total volume divided by VC. VS plus VC divided by VC will give us a ratio which is called as compression ratio. It is also, this compression ratio is also referred as volume before compression and volume after compression. That means the ratio of volume before compression divided by the volume after compression. So what is the volume before compression? The volume at BDC. Cylinder volume at BDC divided by cylinder volume at BDC. This is the ratio R, which is known as compression ratio. So here R is for compression ratio. We have represented this notation R. Ratio and compression ratio mathematically is written as cylinder volume at BDC divided by cylinder volume at BDC. Cylinder volume at BDC can be further divided into cylinder volume, the swept volume plus the cylindrical clearance volume. The swept volume plus clearance volume, that means VS plus VC divided by VC will give you the compression ratio. Then we can divide it by the mathematical rule. So VS by VC divided by VC by VC, this will give us 1. So 1 plus VS by VC will give our compression ratio. All right. So ratio of the volume plus 1 will give us the compression ratio. So these are basic terminologies which are necessary to get understood to understand the engine configuration and the later concepts of the internal combustion engine. So this is all in this engine terminology video. Thank you for continuing with me this video. These are the references which I'm referring to. Thank you for getting them.